Looks like we're up. Okay.
Yeah.
I don't see us on Facebook yet.
Oh, hang on. Let's try this.
There we are.
We're up.
Yep.
Okay.
Hey. We're live.
Hey, we're live.
Yay. Wow, man, what a grooving band. And they fade off into the
Fade
west.
off to black. There you go.
Like a horse and cowboy.
Never had our picture,
No, I didn't.
our fancy picture.
Yes, I
Yeah,
know.
different picture. Yeah.
I had too many screens to look after. Yeah, well, we'll name
Oh,
it.
same thing for
Yeah, you gave
149
up
shows.
too.
It was more important to be live.
That's not an excuse anymore.
We've only done this 149 times.
That's right.
That's right. That's right. Every time is a little different.
Every time.
Hello, everyone, and welcome to our Sunday night offering of astronomy outreach for October the 16th. The Sunday Night Astronomy Show. Wow, halfway through the month already. Hey,
I
howdy.
get my toes out.
My name is Chris Kerwin. I'm the creator of the social media channels known as Astronomy by the Bay. I'm an amateur astronomer here in St. John, member of the Royal Astronomical Society of Canada as well, the New Brunswick chapter. First of all, I'd like to welcome back our regular co-host and fellow RAS member, Mr. Paul Owen from the Moon Shadow Observatory in beautiful Hampton, New Brunswick. Hey, Paul.
Peace.
Sky looks good out there in Hampton right now.
It is. It's a nebulous night.
It is nebulous night. Also like to welcome back our other regular co-host and fellow RAS member, Mr. Mike Powell from the PFO Observatory here in beautiful St. John. Hey, Mike.
Oh,
PFO.
Silent P.
Okay, on tonight's episode of the Sunday Night Astronomy Show. Now, the night sky doesn't have to be complicated. Like driving in an unfamiliar place, a road map is the key. This week, we're going to spend some time looking at some signposts and some star hopping to help you get better acquainted. Also tonight, along with the answer to last week's lunar challenge, Mike has another challenge ready to go. Also, Binal Bud has promised to return with another fine binocular target of the week. Rosanna has provided another fun facts episode that Paul will be delivering for us. And Paul's going to present another astro tip of the week later on. I'll also have a quick view of what to watch for in this week's sky and a couple of things that actually happened this week too that I'm going to mention. And pretty neat things, as well as a look at the highlights in space news. That's what I meant. And I'll have all of your wonderful photo submissions to share too. So this is a family-friendly interactive live broadcast. So for those of you joining us from my YouTube channel or Facebook page, we are happy to try and answer all of your astronomy questions here in real time as well. And of course, we'd like to welcome back all of those who have been joining us through the local Rogers TV network. Thank you for your support.
And hello, New Brunswick News Page.
New Brunswick News Page. Awesome. Great.
Yeah.
So let's get started with tonight's program then, and discussion around signposts and star hopping. Hello from California, Dan. Good evening, guys. Okay. I guess that's me.
Thank you.
Okay, so I'm gonna share my screen here. Let me get this one up first of all. Okay, hang on a second and go back to normal. Back to normal, whatever that is. I guess this one. Yep. Okay, screen one. Okay, you guys are seeing this presentation there, I think.
Yes.
Yes.
Let me take it from the beginning. I should pop up right here anyway from the beginning. There it is. Okay, a little bit of discussion around two things that are up in the sky that most of us know what they are and where they are. And I'm talking about the Big Dipper or Ursa Major. And we'll be talking about Orion a little bit later. And both of these constellations can act as a signpost to get us around to other objects in the sky. So if we take the Big Dipper, for instance, right now, the Big Dipper is fairly low in the sky, but it is available to see. And if we follow through some of the lines through it, we can actually hit several other constellations and several other objects in our sky. So constellations in our night sky can act as signposts, showing the way to other constellations and objects. One of the best is the Big Dipper. Everybody knows where that is in Ursa Major. Now the pictures below show how it's done. So let's take a look at what I mean. Okay, we'll start first of all by drawing an imaginary line through the last two stars of the bowl. And that will lead you right up to Polaris. That's how we find Polaris, our North Star. Now continue on to the Great Square of Pegasus in the constellation, Great Square of the constellation of Pegasus are there. Now another imaginary line, if you drew it from the second star in the handle intersecting Polaris straight through, would bring you to Cassiopeia, the W-shaped constellation there, and then on to the Andromeda galaxy. That's one way to find it. Another way to find it is to take the second part of the W, which is this V that points directly down to Andromeda. And also, you can also take the great square, count out 1 star, 2 stars, up 1, 2 stars, and you'll also end up at Andromeda. But this is the way here that's the easiest probably to find it through the Big Dipper. From there, next we can draw an imaginary line through the top 2 stars of the pot, right there, and that'll lead you all the way to Capella. And Capella is the twinkling star in Auriga. Believe it or not, that one gets called out for a lot of UFOs because it's twinkles so much. Now in the opposite direction, we can take the three stars, the 3 stars in the handle and draw an arc down to Arcturus. And then we spike down to Spica. So Arcturus is in Bootes and we spike down to Spica in Virgo. Let's keep going. We could draw an imaginary line to the right diagonally. And we're going to lead us up to Castor and Pollux, which are Gemini the twins. And then that same diagonal line going the other direction will lead you down to Hercules. And then finally, we draw an imaginary line drawn upwards through the 2 stars in the pot closest to the handle. And they're going to end up directly at Deneb in the constellation of Cygnus there. And one of the stars of the Summer Triangle. I'll draw the same line with an arc to the left of that a little bit, arc like that. And you'll end up at the bright star Vega in Lyra. An imaginary line drawn straight down through the same 2 stars will put you to Regulus in the constellation of Leo. So there we found several constellations, 1, 2, 3, 4, 5, 6, 7, 8, 9, I guess, all by using the Big Dipper as a guide. Now, other thing that we have out in our sky, of course, what's coming up now is our main winter constellation, Orion. Now this is the view at about 2 a.m. So it's a little bit late coming up, but it'll be getting a whole lot earlier very soon. So Orion is also one of the most familiar constellations in our sky. Orion rises around midnight now, but pretty soon it will be a prominent winter constellation. We can use it as a signpost to find other constellations as well as their treasures. So let's take a look at Orion. What can we do with it? Well, we draw a line up and through the stars belt. We'll end up at Aldebaran, which is the eye of the bull in Taurus. Now, Aldebaran is the 13th brightest star in the sky, has a very distinctive reddish orange color, and is an old and dying star. Now, if we placed Aldebaran in the same location as our sun, it would actually extend out past Mercury. Now, extend that line a little bit further, and we end up at the Pleiades, the beautiful Pleiades star cluster. We've also got this drawn for this time of year. Right now, we have Mars sitting there as well, sitting in Taurus right now. reddish Mars. So you can compare reddish Mars with Aldebaran, and you'll see the color difference. Okay, if we take the 3 stars in the belt and we go the other direction, extend the line downward through Orion's belt, will put us at Sirius, the dog star in Canis Major. Now, Sirius is the brightest star in the night sky. Sirius is actually a double star, and it's actually relatively close to Earth, only 8.6 light years away. It is so bright that if it were placed next to our sun, it would be at least 20 times brighter than our sun. So that's down in Canis Major. Now we're going to go the other direction. We're going to go drawing a line upward through the bottom left and through one of the belt stars right through the shoulder, and we'll end up at Capella in Auriga up there. There, how we caught Capella with the Big Dipper as well. It's a yellow star like our sun and the brightest star in the constellation of Auriga. Like many stars we see, Capella has a companion star, but something more than that, for it is actually 2 pairs of binary stars. Another line drawn through the left, through the top 2 stars of Orion, brings us out to Procyon in Canis Minor. Although it's not as bright as its bigger brother, Procyon is still the 8th brightest star in our sky and is about as bright, the same brightness as Betelgeuse is in Orion. Now from there, we're going to go one more line drawn upward through the bottom right star and the top left star of Orion that leads us to Castor and Pollux, the twins again in Gemini. Pollux is the brighter twin star on the left. It is a yellowish color and is about 34 light years away. It's about 30 times brighter than our sun and about 10 times the diameter of our sun. Now, Castor, like many stars, appears as one point of light in our sky, but it actually is a sextuplet system containing 3 pairs of binary stars, all orbiting in a complex way around the central point of mass. Although Castor and Pollux appear together in our sky, the Castor multiple star system is actually almost twice as far away as Pollux is. These stars appear like on a flat plane, but that doesn't mean that they're all the same distance away. So that's what I've got to say about Orion and Signpost. So that brings us to 1, 2, 3, 4, 5, 6 more constellations that you can find by using Orion as your signpost. And that's about it.
That's it.
Makes it sound so easy.
Yeah.
Well, I mean, if you could take a program like Stellarium and just kind of lay it out there and maybe take a snapshot of it, or go back to this slide and take a snapshot of that slide, you can find a lot of things around Orion, especially, and the Big Dipper too. I mean, the Big Dipper really depends on what place it's sitting. Like if it's upside down, it's a little harder to find things that I talked about, but right now it's down fairly low to the horizon.
I tried to photograph it, but Elon Musk started drawing the lines for me, so they were all over the place.
Yeah,
They would be all over the place.
lines for everybody's images.
Okay, so that's a bit about star hopping and finding your way around the constellations using the Big Dipper and Orion as your common signposts. Those are probably the 2 most popular constellations in the sky.
Yeah.
Most of us know where they are. Okay, let's go from there then to how about a Bino Bud next?
Sure. Let's see if I can.
Mono Bud.
I think this looks like it. Try that.
Here you are.
Got
There
it.
he
Here we are.
is. Here he is.
Shows Bino Bud or just show me?
It shows.
Bino.
Thank God, because
Bino
I'm
Bud.
bigger than Bino Bud. So, binocular target of the week this week by Bino Bud is home plate. Sorry, Blue Jays, you won't get to see this anymore this year, unfortunately, but there it is, home plate. It looks just like that, believe it or not. So this asterism field is located just west of M31, the Andromeda Galaxy, which is very conspicuous in binoculars. With a binocular field of view of about 7.5 degrees, you can just barely put the home plate and M31 in the same field of view, believe it or not. So we showed you how to star hop and find your way to the Great Square of Pegasus. And as Chris mentioned, if you go 2 stars over and 2 stars up, you'll find the Andromeda Galaxy. Well, just to the right of the Andromeda Galaxy, right in here, guess what, is the home plate. and you can't miss it. Don't worry about the time over here. I had it up on Stellarium, and it's about 9 o'clock at night. You look east northeast, and there it is. Now, what will I see? Look at this, a perfect shape of a home plate.
Oh, yes.
And it does. It stands out. When you see it, you'll know it's there. 10 by 50 binoculars. Yeah, it's a good size. There's no question when you look up, you find that pentagon, and it stands right out against the background stars. It's actually cool to see. Compared to the full moon, oh, it's at least, I guess, 2 full moons, we'll say, in full size. If you double the full moon, you get home plate. So it's a real easy target to find. Just go find Andromeda, swing a little bit to the right. You again, in 10 by 50s, you'll probably get them in the same field of view. Andromeda and the home plate. And key astronomical moments in history. I told you that was the cat that knocked the telescope, and that's how Galileo found out where the moons were. That's Binocular Target of the Week by Bino Bud.
Awesome.
All right.
Now, how do
Thanks,
I
Mike.
stop share? Ink.
Ink.
There we go.
Awesome. Thank you, sir.
That's a cool target to look at.
It is. They're all cool. Okay, how about Rosanna's fun fact? Can we go with that next? Maybe, Paul?
Oh, sure.
Okay.
Give me 1 second here. I'll get everything all set up here. And that goes over there, and that goes like that there, and then I just got to bring up this here. And put that over there. Click on this. I'm like you. I have too many screens. Okay, I'm just about ready to go. Hang on, just as Mike would say, hold your pickle. Roseanne. Okay, so let me just figure out how I can share my screen. And we're going to start with this week's. Rosanna's Fun Fact.
We're saying about 149 shows, having that ready to go. Yeah, okay.
I was expecting to do this. Normally we do this at the end, and I would have it ready, but anyway, never mind. No, never mind. I'm ready to go. All right. So here we go. All right. So Rosanna writes, throughout history, comets have often been seen as omens of disaster and doom. Soothsayers used the appearance of comets to predict emperors' deaths and climate catastrophes. As recently as 1910, there were reports that the Earth would pass through the tail of Halley's Comet, leading to widespread panic. There were fears that gases would wipe out life on Earth. The Earth will crack, and some crazy things would happen. Thousands will die, and obviously people were just shaking in their boots. This photo, and I better show you a photo. So this photo taken by Hubble Space Telescope shows what seems to be a comet with a spectacular tail, but it's actually an image of Dimorphos and its tail of debris 285 hours after it was impacted by NASA's DART, of course, the Double Asteroid Redirection Test. This is full of positive, important, and a good omen by far. On October the 11th, NASA released the news that although they expected success in the missions of changing the orbit of Dimorphos, their success was even more than they had hoped for. NASA Administrator Bill Nelson confirmed that DART successfully changed Dimorphos' trajectory, changing the orbit around its parent asteroid, Didymos, from about 11 hours and 55 minutes to 11 hours and 23 minutes. So what does that mean exactly? A change of 10 minutes would be a success. This was a change of 32 minutes. This means NASA is a real contender in the defense of Earth from an asteroid hitting on a collision course. It reads a bit like a movie plot, but instead an actual reality. So quick, how many movies can you name that feature an asteroid on a direct death approach to Earth? and there might be more than you think.
Hmm.
Mm.
I won't get people to name them because I'm going to give you a bunch anyway. The day the sky exploded in 1958.
Yeah, a little before my time.
Just not long. Meteor, 1979. Who do you think that is?
Wow.
Sean Connery.
It is Sean Connery.
Some things in here don't react well to bullets.
This movie alone is worth a 3-minute watch. If you want to, we're not going to put it on, but you can watch the trailer for this movie. It's pretty cool. And it's about 3 minutes. While using dramatic sounds of an asteroid whizzing through space, which wouldn't happen as there is no air in space in which sound can carry, the narrator begins describing the impending asteroid strike in panic terms. That was that movie. The Night of the Comet, 1984.
Wow.
Deep Impact, 1998. Post Impact, 2004. Seeking a Friend for the End of the World, 2011 or 2012. And that was actually a comedy and not a disaster. And everybody kind of knows this one, The Good Dinosaur in 2015. And of course, in 1998, and which is probably the one that everybody thought of first, Armageddon. But there are more collisions, Collision Earth 2020, Don't Look Up 2021, and it goes on and on and on. Actually, there are 15 asteroids hitting Earth type movies, but the most interesting one I haven't watched goes like this. Meteor Apocalypse. The asteroid movie stars Joe Lando and Claudia Christian. It's about a massive meteor that enters Earth's orbits, putting humanity in danger. As the meteor starts to disintegrate, it covers the planet with debris. Although the cast is excellent, the dialogue's a little cheesy, and this film shouldn't be taken too seriously. But overall, it's a decent disaster film. So how did I miss this one? How did I miss one? Cheesy dialogue to match the cheesy popcorn. If the wind does blow and the rain does fall this weekend, I definitely will be cozying up, tracking down meteors in the movies at least. And this is relationship. So buddy, they're sitting there he's eating popcorn. She puts her hand out. He says, "Oh, you want to hold hand?" "No, I want chips." And that is this week's.
Rosetta's Fun Fact.
Yay! Awesome.
And as usual, an awesome fun fact. I really, really chuckled when I went through this one.
Mm.
It's really good. How do I stop sharing? Okay. There we go.
That is awesome.
That's a lot of movies.
It's a lot of movies.
You know what? It's amazing there's that many, but it seems every time you turn on the channel, it's either Sharknado or something's in there coming down to destroy Earth.
Yeah.
Sounds no worse than Rocky 14,
Yeah.
It's finally coming to an end. Isn't that great? Now that's a good story. Jamie
Really?
Lee, you gotta give it up, right?
yes, that's right. Halloween comes to an end, yeah.
Yep.
Freddy's done for good.
Very good. Okay, let's do a what's up talk then. Maybe next.
What's up?
What's up, Doc? Okay.
What's up, Doc?
And I guess actually a little bit of my talk is a little bit of repeat of what Rosanna was talking about, though. But
Uh-oh.
oh, see me there? No. Yes. No.
Let's see what's up this week.
Okay,
And
that's it.
text.
That's it. Yep. Okay.
You're holding
Slideshow for beginning. How's this? There. How's that?
There you go.
Okay. What is up this week? First of all, I'm going to talk a little bit about space news because astronomers around the world, somebody sent me this. I looked it up and it was like, wow, okay. Astronomers around the world are captivated by an unusually bright and long-lasting pulse of high-energy radiation that swept over the Earth on Sunday, October the 9th. Now, this emission came from a gamma ray burst, most powerful class of explosions in the universe. That ranks among the most luminous events known. Now, it's located in the Summer Triangle, which is visible in the evenings to the west. With good binoculars, you can see the coat hanger cluster between Vega and Altair, and the GRB is past the open end a few lengths. NASA reported a record-breaking gamma ray burst caught by our Fermi and Swift telescopes, among others. The blast likely signaled the birth of a black hole in a collapsing star nearly 2 billion years ago. A gamma ray bursts are the strongest and brightest explosions in the universe, thought to be generated during the formation of black holes. Though they last mere seconds, a gamma ray burst produces as much energy as our sun will emit during its entire 10 billion year existence. So good thing that we're not really close to it.
Yeah.
And I'm going to go on now to the DART mission that Rosanna mentioned here. Of course, Earth is no longer powerless to prevent potential asteroid impacts after a spacecraft slammed into an asteroid at 22,530 kilometers per hour in the first planetary defense technology demonstration. The U.S. Space Agency's Double Asteroid Redirection Test, or DART, craft hit its target at 12:14 a.m. on September the 27th after 10 months flying in space. Controlled, been 11 million kilometers away. Controlled by the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, the mission was NASA's first attempt to move an asteroid. DART targeted the asteroid moonlet Dimorphos, a small body just 160 meters in diameter. It orbited a larger 780-meter asteroid called Didymos. Neither asteroid posed a threat to Earth, nor do they now. They still don't. The mission's one-way trip confirmed NASA can successfully navigate a spacecraft to intentionally collide with an asteroid to deflect it, a technique known as kinetic impact. The goal was to test whether this technique, called a kinetic impactor, would deliver enough of a punch to a speeding space rock to knock it significantly off course. It did. Before its DART's arrival, Dimorphos orbited Didymos in 11 hours and 55 minutes, a newly calculated orbit, 11 hours and 23 minutes. DART surpassed the agency's minimum benchmark for a successful mission by more than 25 times. We showed the world NASA is serious as a defender of this planet, said NASA Administrator Bill Nelson. That's pretty cool stuff.
Yes.
Both those things, I guess, yeah.
Yeah.
Anyway, okay, let's move on to what is up though this week. So we got all week long, we've got Mercury in our morning sky. Now, if you're up before dawn, who isn't up before dawn though, right? Look to the east for little world Mercury, shining at nearly its brightest at magnitude -1. Now, Mercury passed its greatest elongation, which would have been up here from the sun last week. Now, with the steep angle of the ecliptic, that steep angle that the planets make in the morning sky, that placed Mercury high enough to be easily visible. Now it's quickly settling back towards the horizon, so try to catch it this coming week. This will drop very quickly in this direction. It only takes 88 days for Mercury to go around the sun, so we don't get to see it very often in the morning or the evening sky. Now, the evening planets, though, we got a nice show out there still continuing. We are still able to enjoy the two gas giants, Jupiter and Saturn. This week, Mars is up in the east at about 9 p.m. now, so 3 wonderful planets to view in our evening sky for a while longer. In fact, it'll be late December before Saturn disappears from view, and late February before Jupiter disappears. Our best viewing for Mars arrives actually in early December, December the 8th, when Mars is at opposition. On that same date, the moon is going to pass in front of Mars. Now, Monday, we've got the third quarter moon. Third quarter moon appears a week after the full moon and 1 week before the new moon. Now that day is tomorrow. A third quarter moon appears half lit by sunshine and half immersed in its own shadow. It rises in the middle of the night, appears at its highest in the sky around dawn, and then sets around midday. The third quarter moon is a perfect time to get out with your binoculars and check along that line, that terminator line. Lots and lots to see there. On Tuesday, we have an Io transit and shadow egress. Now, this is going to happen in the daytime, but we'll get to see the egress as they're leaving the surface. So on Tuesday evening, little Io, one of Jupiter's Galilean moons, transits across the face of the giant world. From our location, we won't be able to witness it easily, as it will begin when the sun is still up. But we should be able to catch its egress, or leaving the surface there from the planet, a little bit later. So Io's transit egress begins at 7:17 and its shadow egress begins at 7:52. So you'll have that little bit of time there to catch both of them. You'll actually see the Io out here very, very shortly after it egresses. Still nice to see that the fact that we can see Galilean moons leaving their shadow on bigger worlds. On Friday, October the 21st, you have the Orion meteor shower peak, Orionids. The pre-dawn sky is moonless on Friday morning, offering a good chance to catch some meteors of the Orionid shower. Now that's debris actually from Halley's Comet. The shower's origin point, the radiant, which is right here, will be the highest in the hour before the first sign of dawn. So this is when the shower will appear the most active. You might see between 5 to 20 meteors per hour, depending on your light pollution. And we're going to go to the zodiacal light now too. Over the next 2 weeks, starting next week, the zodiacal light is a cone of eerie light above the sunrise or sunset point on the horizon. Now you'll see it before morning dawn breaks or after evening twilight ends. But on this case, it's going to be in the morning. If you're in Northern Hemisphere, the weeks around September equinox are your best chance to see the zodiacal light in the east before dawn. The light looks like a hazy pyramid. It appears in the sky just before true dawn lights up the sky, or true darkness falls in the others on the west. The darker your sky, the better your chances of seeing the zodiacal light. Next new moon is on the 25th, which means the moon will not be in our early morning sky around that time, so it won't be bothering us for a view. So if you're out in a dark sky site, look for that faint pyramid shape, and all that is dust in our solar system. Light scattering off of dust in our solar system. I'd like to bring up Lisa's Lookup, Astronomy and More. This is her chart that she puts out every month. She lists the events here. She lists the date of the event here, the peak time, and what you need to see it with, naked eye, binoculars, or telescope. Now you can follow her at Ruby Moonbeams on Instagram, Twitter, or Facebook. Lisa's Lookup. And our local St. John Astronomy Club and the Royal Astronomical Society of Canada, the Brunswick chapter, we put out this calendar every month, actually in October, November, runs from October 2nd to November 12th. And in here, I pick out a lot of the things that are happening, and that's what I show on the WhatsApp talk. We do have another Irving Nature Park event planned for October the 28th. And the backup date is going to be the 29th. So just to remember that that's there. I'll be putting a post up on my page to let people know about it more a little bit later on. And that's all I got for that.
That's all I get to say about
That's a lot.
Yeah. Well, there's not something every day, but I mean, there's still lots of activity, and we still got a lot coming up. Like in November is going to be a really good month. We got November. We have the total lunar eclipse coming up on November the 8th.
Yeah,
which comes up in the morning sky. So I'm going to be live on that one. I don't know whether I'm going to be live on both Facebook and YouTube, or maybe just on YouTube. Sorry, because everybody can get to YouTube, but not everybody is on Facebook. So YouTube might be my choice, and if that's the case, I'll let everybody know ahead of time. I'll put up an event post anyway, and that takes place at 4 in the morning on November the 8th, and it sets as the moon sets at 7:30. It's still eclipsed while it sets, so it should be a nice big beautiful orange as it's setting as well. Okay, that's coming up then later on, but for tonight, let's go with what are we up to now? How about a lunar challenge?
Sure.
Okay.
We should have binocular lunar challenge coming to life here.
We do.
Awesome. So, me being me, I didn't research this as much as I should have, because you know how the phases of the moon go. And unfortunately, I I should have picked craters on this side of the phase, and I started focusing on the first quarter and the first half. But anyway, you got a whole reprieve here for a little bit before you get out to have to continue this challenge. How's that? So binocular moon challenge crater or moon crater challenge this time is Well, last week we showed Aristoteles, and there's the picture of it. We've already seen this one, and there's Aristoteles right above it. Somebody gave a good hint last week, so it should have been easy to find. And apparently we got some pictures to show a little later. Then that's pretty cool, and I love it if you can show me pictures of it. But this week we have, how do you pronounce this? Theophilus? Theophilus? I can do that. The rim of Theophilus is wide terraced inner surface that shows indications of landslips. Is 100 kilometers wide and 4.2 kilometers deep, with massive walls, and has broken into a second formation. Now, how do you do this one? Cyrillus?
Cyrillus.
Cyrillus? Okay. So it's, see, I'm not good at these words anyway. Anyway, this was created during the,
Aristotelian.
Yeah, that period. 3.2 to 1.1 billion years ago. The floor of the crater is relatively flat and has a huge, large triple-peaked central mountain that climbs to a height of about 2 kilometers above the floor. The western slopes of the ridge are wider and more irregular, whereas the peaks descend more sharply to the floor in the northern and western faces. Apollo 16 mission collected several pieces of basalt that were believed to have been ejecta from this formation of Theophilus. How's that?
Awesome.
There is a picture of it. You can see the nice terrace sides, the crater and all the center peaks and all of that. And there's one big crater down here at the bottom. So if you can go out and find that and get a picture of it or look at it, then you caught up to our challenge of the week for the moon. And
awesome.
That's that.
Thanks, Mike. So yeah, I do have a couple of photos to show tonight that people had captured, and I want to let everybody know too that we are putting those photos into a draw. There will be a draw at the end of the month for a couple of nice prizes. So we'll expect your photos. Send them in.
It's even funny. I go on Google Translate or Google Pronounce, and I listen to these words, and then when it comes time, it's like.
Even if you end up going out with binoculars and catching the moon with binoculars, and you catch that point and you bring it in and you get a map of the moon and you point it on the map, that's fine. We'll accept that.
Just find it.
Just find it. That's the main thing. It's a challenge, right? So
that's right.
Okay, awesome. Thanks for that. How about we go with an astro tip, Mr. Paul?
Okay. Sure.
Don't eat yellow stars.
All right, I'm going to try to share this screen over here this time. If I go like that and share screen. Here we go. All right, so what I'm going to do is I'm just going to do a brief little rundown on a follow-up of last week, where we were talking briefly about the history of the telescope. Is that up? I can't see anything.
Yep.
Is it? Okay, you see my mouse?
Yes.
Okay. All right, so today's telescope's design, as we talked about last week, there are a series of telescopes, but the main ones that are out there these days are the refractor, which is the first one, and the one that, of course, Galileo Galilei was famous for. Didn't invent it, but was famous for it. And then there was the Newtonian, which of course Sir Isaac Newton was famous for and did in design. And of course the Dobsonian, which is a Newtonian with a twist, and so to speak. I guess that's really a twist and a turn up and down. The Dobsonian, and of course the catadioptric, or the compound, or the Schmidt-Cassegrain telescope, as we've all come to know it. So with these four designs, they all have pros and cons. And the reason I'm trying to bring this up is because a lot of people now, now that we're coming into mid-October, coming into November, are going to be starting to do some Christmas shopping, and they may want to go out and buy some telescopes. So when you do, each one of these designs has pros and cons. And I just want to kind of touch base on some of them for each of them, so you can get an idea, based on what it is that maybe what you want a telescope to do. So let's just go right down to the pros and cons. I'm not going to get into light paths and how they're built and all that stuff, because we kind of covered that last week. But what I do want to cover is what are the pros and cons of each of the telescopic designs? So let's start with refractor, because that's where we began to begin with. And so the refractor, so the pros, the good things about refractors, first of all, it's a classic design. There's no obstructions in it. It goes right directly from the lens right down to the eyepiece. Good contrast, no collimation. Usually you can collimate a refractor, but in most cases you do not have to. No thermal degradation, and excellent for imaging. Also excellent for viewing. A refractor is smaller, but very, very good for viewing. Now the cons, the things that aren't so great about them is they are the most expensive per aperture. So depending on the size of the objective that you want, they can get relatively expensive because there are a lot of money to figure to get those optics looking the way they do. Larger scopes are very long. Now, the problem with that, of course, is if you're wanting to look up near the meridian and it's a long telescope, you're going to be laying on the ground. So you don't want to be doing that. And also, chromatic aberration is less in expensive models. And chromatic aberration, for those who don't know what that is, that would be that color fringing that we get, the purples and the greens and stuff outside some of the brighter objects. So the more money you put into a refractor, then the better the glass is to eliminate those issues. So that's refractors. For Newtonians and Dobsonians, and the reason I put these both in the same category is because they both are basically the same kind of telescope, except one rides on a mount, which would be the Newtonian, and one rides in its own little cradle, which is the Dobsonian. But the scopes themselves are the same. So the pros, the good things about these designs, first of all, they are inexpensive to manufacture, and they are inexpensive to buy. The largest aperture for the money, or as everybody's heard this a million times, the biggest bang for your buck. There's no chromatic aberration in Newtonians or Dobsonians, which means, again, you're not going to get that color fringing. And there are various designs available. And this, everything we talked about includes the Dobsonian in that design as well. And the other pro about the Dobsonian is you do not need a mount. You just take the cradle with you, plunk it on the ground, put your Dobsonian telescope in it, and then you're good to go. So you don't have to do any balancing and all the other stuff you have to do typically with other kind of mounts. Now the cons, the things that aren't so good about that design is they require collimation. Once you know how to do collimation, it's very simple. It's less than 5 minutes and you're good to go. It'll become just like setting up your scope, which is part of what you do. So it's a con until you get used to it. It's an open design, which means that at the end of the telescope, it's wide open. That means things can get in there. So you got to be careful about dirt and dust and rain and all other stuff getting down there, critters, creatures, and so on. They're very large to handle on mounts, not the small little 150s, but you get into those 10-inch Newtonians, they're big and they're heavy. And the wind just looks at them like it would a sail. So you got to be careful of that after using them for imaging. And you have to choose the focuser based on whether you're going to be observing with it or whether you're going to be imaging with it. Because if you're going to be imaging with it, you need to have a very different type of focuser that'll work well for that, and also how it places itself in the telescope so that you can come to focus. And there's also coma. Coma would be these little arrows you might see in the corners, and you can get coma correctors, but it's an additional cost. And finally, the Schmidt-Cassegrain. Now, the Schmidt-Cassegrain is that compound one. That's the one that has both design implements in it. The lens, of course, from the refractor, and of course, the reflector type of scope from the Newtonian. So the pros for a Schmidt-Cassegrain is they're very compact. Even the largest, most powerful ones of those, although a little heavy, are compact enough for somebody on their own to move. They're very portable. The viewing is always comfortable with a Schmidt-Cassegrain telescope, providing you set your mount up on the proper height. They're very flexible with accessories. So just to give you an example, it's the most flexible telescope for focal lengths. because if you put a 2 times Barlow on it, you can get right out to 4,000 millimeters if you're using an 8-inch telescope. If you put a reducer on it, you can take it right down to 1,400 millimeters. The native focal length of it is typically for an 8 inches around 2,000 millimeters. If you put what they call a hyperstar on the front of the telescope, and if it's hyperstar compatible, you can take that right down to a 540 millimeter telefocal length. So that is the most versatile telescope that's out there. But now the cons, they can be very expensive, which we just had a conversation before we started the show, and we can't believe how much these things have gone up in price. Long cooling time. Now, the reason for that, of course, is larger mirrors means more cooling. When you're also sealed from the front and sealed from the back, there are tube currents inside there that also need to acclimatize. So they take a fair bit of time to cool down. Larger primary mirror requires collimation, not as much as an Newtonian. So to collimate a Schmidt-Cassegrain is actually very, very easy. It's generally done just from the front with the 3 screws on the end of the secondary mirror. And other than that, that's pretty much what I want to cover. I just want to cover the pros and cons of those 4 design telescopes that we talked about last week, which are these ones right there. So if you're going out to the marketplace and you're looking for a telescope, bear in mind some of these pros and cons, and hopefully that'll help you a little bit on your journey of buying a telescope.
Awesome. Thanks, Paul. Also, I wanted to mention too that we do have a beginner's workshop coming up on Tuesday, the 25th at the Rockwood Park Interpretive Center. People can send me an email through this Sunday Night Astronomy Show at gmail.com if they're interested in attending. It's registration, just because we need to know how many people will be showing up. It's free. It's a couple hours, and Mike and Paul and I are going to get together and help you choose astronomy gifts for Christmas. Say you're looking at a small scope, or maybe you're looking at a special book or a pair of binoculars or whatever. We're going to have an on-site workshop with our suggestions of what you might purchase in categories of dollars, basically. So looking for something for yourself or something for one of your loved ones or whatever, stocking stuffer kind of thing or whatever, well, come see us at the Rockwood Park Interpretive Center, but we need to have you registered first so that I know the numbers that are going to be there. Can't exceed their numbers. So send it to myself, Sunday Night Astronomy Show at gmail.com. Okay. Perfect. Thanks, Paul.
Yeah.
Good information. Okay. Let's go then to some photos. Okay. Rudy. I'll share the screen. Same one that we're on, but I think I can do it this way.
There we go.
Let's show it. Yes.
Yep.
Yes, yes.
Okay. Now you got to get my notes up. There. Okay. So we got. I'll get bring my notes on another page. Hang on. It's not going to let me. It's not going to let me go back or forward because you 3 guys are stuck here on the side. Hang on. We'll have to switch screens again. Stop sharing for a second. I'll bring it up down here. And we'll try it once more. Okay, that should give it to us anyway. Taskbar is down there, but that's okay. Okay. Yes. Hello?
Oh.
Yeah, is it up?
Yeah.
Okay. Hello? Anybody else on here with me? Okay, this one comes from Joey Craswell sent this one. He said, photo taken by Dan Craswell, his wife there, picture of the fall colors with the full hunter's moon and Jupiter from Keswick Ridge, New Brunswick, while camping in Mactaquac, taken with a Nikon D7500 and 200 millimeter lens, edited with PicMonkey on cell phone.
Right on.
Well done.
Yeah.
Well done. There it
Bridget Green, there it is. Hey there. She says, this week I'm using the same photo as last week as I missed any clear opportunities that we may have had during the past several days. That's okay. And
I
I'm
love it.
trying, and I'm trying to avoid referencing other features that could be used as future targets to locate. So I will keep it simple. I'll keep it simple, she says. Aristoteles is the larger crater above and off to the right of the last week's target. That's it.
It is. You
Yeah.
nailed it.
Good stuff, Bridget. You're in the contest now. You're in the draw.
Awesome.
I got this one from Corinne. She said, "Hi, Chris. A few Hunter's Moon shots. Great shots there,
Very nice.
Corinne.
Oh, yeah.
Yeah.
Look at that. Beautiful.
Nicely done. Yeah.
Yeah.
Thank you for those."
Very nice.
Lisa Fanning sent this, and hi, Chris. Here's my submission for the Lunar Crater Challenge at Aristoteles. Thanks for adding this feature to the show. It's really fun. I have to mention that to Mike, because Mike is the one who suggested it. Hi again. She says, I also caught it on the daytime moon. I'm going to show you that shot in a second.
Oh, sweet.
There it is.
Look at that.
Yeah.
Very nice, Lisa.
Thanks for getting us all to look up, she says. Thanks for taking part, Lisa.
Yeah,
And
awesome.
you're entered in the draw as well now. Got this one from Mr. Paul Crowder. Hi, Chris, and
sir.
greetings from the UK. He says, yet another old capture revisiting, showing the location of Mike's Lunar Challenge target. There's
That's
right there.
awesome.
Aristoteles crater, coordinates 52.2 degrees north and 17.4 degrees east. Thanks, Paul, for that. Appreciate that.
Very much.
We're going to go on to Rob Fanning. Rob sent this one. He says, hi, Chris. I took this moonshot at Princeton University campus this morning. Fall is here in the Garden State, he says.
Wow.
There you go. Same moon. Look at that.
Nice.
Gorgeous color.
It looks like the same moon.
You think it's a different moon?
Same one that we see. Thanks, Rob. Matthew Dupre sent these in. He says, some submissions for the week. One is some reprocessed data of the California nebula.
Very nice.
Very nice. Thank done.
That's good.
And the other one is of the Northern Lights of last week, he says.
Oh, right on.
Yeah.
He must live in the middle of the Northern Light District.
Yeah, I tell you, gets a lot of shots.
Lucky
Him
guy.
and yeah. Very well done.
Yeah.
You know, Audrey Coram Sanaka sent these in over the Thanksgiving weekend. She said I had a bad fall. On the different trips to the ER, I had to stop and get a few photos of the moon. Now there you go. There's
That's dedication.
there's dedication right there. Right? Yeah. She said as it set and again as it rose. My shots are not the best due to compressed elbow that made my holding my Nikon P1000 very steady. I thought I would share the photos I took with you. One of your Sunday night Facebook Live editions that featured how to take photos with something in the foreground. There you go, Paul. Inspired some of my shots.
There you go.
I look forward to learning more about taking photos, as I am not very knowledgeable on photography. Now, when I went to Facebook, she sent me 8 photos, but Facebook only lets me download 3 out of 8. For some reason, it won't let me see the rest of them. So these are the ones she sent.
Oh, nice.
Hey, for her, astrophotography takes patience.
Yeah. Yeah.
Tough room.
Tough room. Whew. Right over. Anyway, very nice.
I can't believe the dedication.
Yeah.
That's awesome.
On the way to the ER, I saw the
Exactly.
moon.
Pull the
Awesome,
ambulance over.
Come on there, buddy. Take that cord out of me. I can take a shot of the moon.
That's
Great,
hardcore,
Audrey.
all right, Lisa.
Thank you, Audrey, for those. Okay, Derek Wasson sent this one. And he said, "Moon, I was just using my Samsung Fold 4." He said,
Yes,
"Good
sir.
shot. Well
Neat,
done."
eh?
Yeah.
That's cool.
Yeah.
And Kimmy Williams. Now she sent one in to us before from was it Switzerland last week? Sweden or somewhere. Anyway, her friend was on her way to Nairobi, Kenya, and she didn't remember seeing the moon up at the same time. So her friend took this picture from Nairobi, Kenya, and sent it to her. So she
Oh,
sent it to me.
wow.
Yeah. So there's the
That's
moon
cool.
from Nairobi. Yeah.
Very nice.
Well, thank you for that, Kimmy. This is from Carol Bean. Carol says some shots of the full moon rising above St. Stephen.
Beautiful.
That, eh? Yeah.
Yeah.
Well done. Thanks,
Yes,
Carol.
sir. Oh, yeah.
Yeah, very nice.
Perfect.
And Mark sent these in. He said, get prepared for a snowy winter, Chris, he says. Hornet's nest up very high means lots of snow as of Thursday last week. Well, let's hope you're wrong, Mark.
Yeah.
I hope the snow doesn't get that high.
Almost looks like a space trooper.
Does, eh? Yeah. Anyway, if you'd like to send your pictures in, we love getting them here. So you can send them into SundayNightAstronomyShow@gmail.com or SNAS@astronomybythebay.ca. And we love to share them. Thank you for all those submissions. As I mentioned, we are collecting all the photos for a draw at the end of the month for the Lunar Challenge. Okay, so I guess in closing then tonight, next week's show will actually be our 150th episode, 150 shows.
Wow.
And, we're not going to do anything really special. We might wait to the 200th show for that, but we'll be talking about white light solar filters. Mike's going to take that talk away.
If you want to.
Hmm?
If they want to send cake in, they can.
Cake, we can always accept cake or cookies.
Cookies are acceptable too. Yeah.
Yeah, either one. Where do we send them though?
To
Virtually?
SNAS.
They can send some virtual cookies. SNAS, yeah. Okay.
Actually,
Anyway, next week is 150 episode for us, and we'll be talking about white light solar filters next week, which kind of fits in with all the action on the sun lately. If it's a clear sky, we might try to offer something through the telescopes, possibly, guys.
Yeah, possible. Anything's possible.
Yeah, if it's a clear sky, kind of what we started the show for in the first place, 150 episodes ago.
Yeah.
So we might be able to offer something with a clear sky. We'll keep our fingers crossed to see what happens. Anyway, okay. So in closing, then tonight, we thank you once again for your continued support of all of our efforts here. Special thanks again, of course, to Rosanna for continued contributions to our program. Rosanna, thank you very much. We really do appreciate it. We also hope that all of you who have joined us from the Rogers Network enjoyed the program tonight. If you would like more information about the wonders of the night sky, you can find me at astronomybythebay.ca on all the social media channels. Also, a special thanks to all of you who share our program out there. We really do appreciate it, especially Trudy. Shares a number of places for us. Thank you, Trudy. Remember, too, we do love getting your photos, so send them into SNAS@astronomybythebay.ca or SundayNightAstronomyShow@gmail.com, and we'll be happy to include them on our next broadcast. Now, if you have suggestions for a topic for a future show, please let us know at the same address, and please let your friends and family know that we are back here again next Sunday night at 8 p.m. on YouTube and Facebook to entertain you on astronomy and the wonders of the night sky. So for now then, from Mike, Paul, and me, we wish you a safe week. Lots of clear skies, guys. And as we like to say, open your eyes to view the skies and keep your scopes pointed up. Good night, everyone. Thank you.
Uh-oh.
Uh-oh. Get any music?
Whoop,
Mr. Music,
fumble.
please.